first let's check custom types. Custom types. Defining custom types. Um, Aiken's custom types are named collections of key and or values. They are similar to objects in object-oriented programming languages, though they don't have methods. Okay. Uh, Custom types are defined with the type keyword. So if I wanted to create a custom type, I'll have to use the type keyword, just like they did here. They may contain named fields or not, but they cannot mix. Okay. With named fields. So they created the name datum, and you can, so the datum can only be of the type datum. Okay, here we have defined two custom types called datum and datum nameless respectively. The constructor of datum is called datum, and it has field a signer, okay, which is a byte array, and a count field, which is an integer. The constructor of datum nameless also has two fields of the type byte array and integer. Okay, byte array and integer. Oh, I think I understand. So they are basically saying to create a type which has two named fields, which is signer and count. This is how do you do it, but you don't necessarily have to like name your fields like signer or count. You can directly give it like nameless fields, because by the end of the day the fields will change into numbers inside of the computer's brain. This will just be like 0, this will be 1, and if you add another one it'll be 2, like that. It'll just keep indexing. So here it's already knows 0 is byte array, 1 is integer. Does that make sense? No? Yes?
Yeah, it is.
Um, so once defined in the custom types, calling their constructors, you just call this. If you want to build this type, you call this constructor. So it constructs this type for you. Okay, perfect. Shorthand notation. Because single constructors are quite common, there exists a special shorthand notation where the type and the constructor have the same name. So
Right.
instead of the above, one can write this. So you can directly do this.
And that's what we normally see. Actually, most people are using the shorthand.
Yes, yes. Unless this type has like, this type can be
Oh,
of two different ones. Say, for example, let me quickly write this. So here I want to just define some types. So I'll use the type keyword, and we'll call it person. And the P is capital, by the way. And let's see how they have done it. And then they use like these flower brackets. But here I can say person 1, and this will have one name, and it'll be a person 2 with an other name. This is, I'll call this name 1, and I will call this name 2. So now person can either be person 1 or person 2. And if it's person 1, it'll be name 1. If it's person 2, it's name 2. But technically speaking, the name 1, name 2 don't matter, because this will always be 0. It'll be indexed as 0. Person 1 indexed as 0 is byte array. Person 2, oh, this also. Okay, so I have created this, but we cannot use the shorthand for this. Does that make sense? We cannot use the shorthand notation for this. We cannot use this shorthand notation for this,
yeah. Why
because there are
not?
two types.
I see. Yeah, yeah, yeah.
Here, if there is only one type of datum, the name and the constructor can become the same thing. So here,
Right.
person is the name of the type. Okay. Person 1 is the constructor for the first type. Person 2 is the constructor for the second type. But both of them are of the same higher type.